upload it. Okay, but I still expect you to come to class on time. Okay, what's going on here? Okay, now my name is Christopher Yang, and if you have questions, and you can ask me during the class, and at the same time, if you have questions after class, you may email me, Avenue to Learn, and I'll try to answer your questions within a day or two. Okay, I am not a full-time instructor. But I'm doing this class part-time since 2013. So I really like FEA, and hopefully you like it too. Okay, back to the question. Do not expect that I can record everything due to technologies, uploading, try to come to my class in time. Okay. Okay, okay, you will have this class every Saturday from 9 to noon, depending on the progress. We might not go over, we might not need 3 hours. Okay, for 3 hours, that's including in-class assignment. But now we are doing the distance learning, or the in-class quiz or assignment. You can do it after class, right? So I expect to have the class shorter than this. Okay. Okay, back to the question. So is it recording? I will try to record it and upload it as I promised, but again, please don't count on it. Well, when we're doing the in-class, in-person lecture, I don't think I record everything. If you miss the class, that's it, right? Okay. Okay, you will have 21 hours of classroom lecture, 18 hours of a lab. So total will be seven weeks of lecture with up to 5 to 6 weeks of answers lab. Okay, I will talk about that in the near future. Okay, is this course difficult? Let's talk about it later. The first thing is I want you to learn something rather than get a good grade. But okay, textbook. This is the reference textbook, FEA by Said Movini. You don't really have to buy it because my course notes are very good, and my course note is based on this textbook. So you don't have to buy it unless you really have to, unless you really want to and want to explore more about FEA. The prerequisites, I don't really know what they are, but if you want to do well in this course, there's a lot of materials you need. You need to work on matrix operations, a lot of matrix operations, and a lot of the trigonometry. Okay, today's week 1, and it's May 8th. I will show you, we're going to go over some simple elements, the rod elements, and we might go over the plane truss elements as well. It depends on the progress. The week 2, we're gonna do some theory. What is the first principle of a finite, first principle to develop a finite elements. Week 3, we might do more potential energy approach in terms of an elements development. And then we will do something on beam theory, beam elements theory, frame elements. Okay, tentatively, I'd like to schedule week 4, May 29th, to the midterm test and assignment. But again, this is tentative, depends on progress. I might delay it. Okay, after the midterm test, we want to take a break from theory. Okay, you have 5 weeks of labs, lab 1 to lab 5. Okay. However, Ansys, the student version, is only for Windows PC. Any Mac user here? Okay, for all the Mac users, there are a few options for you. You have to borrow a PC from someone else, because somehow you're not able to download the Ansys with a Mac. I don't know why. Ansys and Apple, they don't get along very well. So only the Microsoft operation system can download the Ansys. Okay, either you can borrow a computer from your friend or family. Usually in class, we all the computers in my master is already have the Ansys application in it. But now, due to distance learning, please get a computer. Okay, but if you really do not have, you're not able to borrow a computer, you may do the assignment, the lab with your friends, and then write your own reports. Okay, and for the Ansys midterm, okay, there will be 5 labs and 1 midterm, and probably, if you really lack of options, talk to me. We might arrange something else. Okay, after 5 weeks of labs, we'll go back to the we'll go back to theory. We're going to talk about 2-dimensional finite elements. And finally, for the last 2 weeks, we're going to talk about dynamics, thermal stress. And again, tentatively, July 24th, we'll do the final exam. Any questions so far? Okay, now back to when student asked me, is this class difficult? Is it easy? Is it hard? If you work and if you understand everything, this class is easy. Okay, but okay, your course outline is within the Avenue to Learn. It's uploaded. Okay, it's in the overview section. Okay. Okay, we will have, okay, usually when we're doing the in-class, in-person lectures, you have up to 5 or 6 quizzes. Okay, I will, every week, I will give you a lecture, and then after the lecture, I give you a quiz on previous week, and because this is a distance learning, all the quiz are turned to homework now. Okay, and I will issue up to 5 or 6 quizzes, and I'll pick the best 3 or 4, again, based on your progress. And the total weight of the quizzes assignment will be 10%. And then for the midterm test, we'll be covering the first 4 weeks of lecture. And then that will be 20% of it. And that will be up to five labs, okay? And then depends on the progress, I'll pick the best 3 or 4 labs, okay? And then we will be weighting 10% of it, of the total score. And at the end of the lab session, there will be a final project, okay? And again, all labs and project will be based on answers, okay? That answers lab project is kind of like the midterm test, that's 20%. And finally, your final exam is 40%. I'm not quite sure what you mean by protoring. Anyways, you can email me at the class. Okay, so do you have any questions on the course outline so far? Anyways, you may speak if you want to. At the beginning, I mute everyone because this is due to some noises. Okay, I just want to know, did I just unmute everyone and you're not able to speak at all?
No, we can talk.
Okay, sounds good. Yeah.
No, we're not muted.
Okay, sounds good. Perfect. All right, let's do some work. Okay, all the notes are already uploaded, okay? But in my class, we'll just go over the notes with you, explain what's going on. For week 0, okay, this is your homework, okay? And I want you to understand how to do some matrix operations, okay? How to multiply matrix together. Don't worry, guys, this is nothing fancy. This is all your high school notes, basically. Okay, the matrix contains rows and columns. What is a diagonal matrix? What is a unit matrix? Okay, and the matrix rules, right? When matrix A times B is not equal to B, matrix B times A. Okay, please review that. Okay, let's begin first class. Okay, why are we learning FEA? Okay. Well, in the old days, right, when we need to, oh, by the way, if I had some lectures, which is recorded and uploaded to YouTube already. I have inserted the links to all the course notes. Okay, you may review that. This is from my last year class. Okay, those lectures are already updated, and it's it's not like the live recording. It's unedited. It's course. Okay, so if you want, if you don't understand what I say today, you may review those YouTube videos. Anyways, okay, so why are we learning FEA finite elements today? In the old days, before we have FEA, we want to design something. Let's say we want to design a chair. Oh, this is a very bad looking chair. Okay, we talk to the customer. Okay, your size, how tall are you, how big are you? Okay, and then finally, we want to analyze the weight of the customers, depends on the weight, and then we'll do some testing. Okay, so we'll design a chair which is strong enough for it. So if this heavy guy, we have a thicker legs. Okay. But because that involves a lot of testing, and testing is not cheap, and it's also wasting a lot of time. And also it's dangerous, right? You seriously, in the old days, all the structure design, relied on tests a lot, and it hurts people. So because of this, we developed the finite element, which can save a lot of money, time, and because it's a lot safer, so you save life as well. Okay, no one get hurt. Well, let's say those are the things. You know what? Those are things company would like to hear. Okay, let's say in the future you go for a job interview. Okay, if you say that you have a skill set that can save the company money, save the company time, and it's very safe. No one get hurt during during that exercise. Might not guarantee you to get a job, but that's the things they like to hear. Okay. Okay, so today I'm going to introduce a very simple, the simplest elements to you. Okay. Okay. The most simplest element we have is the spring element or the rod element. Okay, so what is rod element? Of course, it looks like a rod. Okay, let's for this. In this example, I'm gonna show you a cylinder, a rod. Okay, and the strength, the stiffness of this rod depends on three factors. Number one is the cross-sectional area. Well, obviously, if the rod is thick, it's stronger. If it's thin, it breaks easy. Second thing is the materials. If this wood is weaker than steel, so is the elasticity. Okay, all materials is given with a elastic module. Okay, and you you can get it from the website, or it's always given in the questions. And finally, the length of the materials. Sorry, length of the rod. Okay, if it's longer, it's stretched longer, it's weaker. If it's shorter, it's stretched less. Any questions so far? Okay, it's complicated to draw a rod all the time, so I simplified it into a spring. Okay, what is the definition of a elastic modulus? Okay, it is the stress applied to the material over the strain. And we all know the stress is the force being exerted in an area normal to the force. Okay, and the strain is the changes to the material length over the total length. So we just arrange the formula a bit. Move this over. We move A over the other side. I have just invented a new term. It's EA over L. And I call this term K. So each spring element has a K value. And you can stretch it. It will bounce back. Let's see how to use it. Okay, let's define a reference frame. So I draw that spring elements again. The whole thing is called elements, okay? And each element has two nodes. Let's call it node I and node J. Okay, nothing fancy. So far, I just name an element, okay? And then we have two nodes on it. Okay, each node, something happened. On node I, it's able to move. By how much? By UI. And a force. Why is it moving? Because there's a force attached to it. There's a force acting to it. So force I is pushing node I and is moved by UI. Same thing happening to node I. There's a force acting on node J. So the force J is acting on node J. So it moved UJ. So any questions so far? Guys, it's very important to know the basic of the finite elements because if you do not understand the basic, it's hard to go on. Okay, it's like building. It's like doing a building. You need a good foundation in order to do well in finite elements. So any questions so far? Okay.
Professor,
Yes, what's up?
could you just scroll up for 1 second, please?
Go what?
Could you please scroll up for just a second?
What do you mean?
Move your
like,
notes up, move
yeah.
your notes down a little bit. Yeah,
Oh, yeah, that's it. Thank you.
By the way, that that note is already uploaded as well.
All right, thank you.
Hey, by the way, you may write notes with me, but seriously, you don't have to, because everything's uploaded. Okay. Up there, we develop equations. Force equal to K delta L. Right? So let's use it. Let's define force I first. Force I equal to K. So what is delta L in this case? Delta L is because I'm standing on node I. Okay, I'm standing in node I. And the difference between node I to node J okay, that's my first equations. Now let's do the same thing. Force J. Force J equal to K. Now I am standing in node J. Okay, and the difference from node J to node I is UJ. Okay, any questions so far?
Why wouldn't the change in length be like the amount that, say, node I, the change in
Well-
position for node I? Why is it UI minus UJ? That's like the overall length, isn't it?
It's the changes. The overall length is given. It's before I have, okay, the overall length is before I have Fi and Fj on it. There's no force acting on it. That's the overall length, the initial length. However, I am acting some force on it. Fi, Fj, I'm acting some force on it. Because of the force, I'm changing. Because of the force, I'm changing the length of the cylinder. And what's the change? I need to measure that, right? Because I'm acting on I and acting on J as well. So they both are moving. Fi is moving. Fi is moving node I. Fj is moving node J. They're both moving. So I need to measure what's the difference in between them. So that's why I use Fi minus Ui minus Uj. But for the second equations, now I'm standing on node J, okay, and I need to do the measurements, the difference, right? So I use Uj minus Ui.
So
When you
they will
define,
be,
yeah. Yes, sorry.
one will have a negative sign then, like
Oh,
magnitude.
don't-
difference?
You're thinking ahead. Don't think too much for now. Okay. I am so stupid. I see nothing. I just see I'm standing on J and I'm starting on J minus I. When I'm standing on I have I minus J. That's it. I'm standing where and then I define from there. Good question though. Yes, you will have a negative, but this explains you why is it negative though? Okay, let's move on. Let's rearrange that a bit. K U I minus K U J. And F J equal to N. You expand the term. And then minus K U I plus K U U J. Any questions so far? I just expand the terms, okay? And then I rewrite both equations into matrix. I further expand it. So now you have a three mass, okay? This is called the force vector. This is the stiffness matrix. And this is the displacement. Okay, so this vector will tell you all the information regarding the force. This stiffness matrix tells you how strong that element is. And finally, when the force acting on the element on the stiffness matrix, you have a displacement of the vector. Okay, the best things to learn something is do an example. Okay, again, example 1. That note is already in your uploaded in the Ever to Learn. Okay, you can write along with me, or you can just review the note yourself. Okay, the initial length of this element is 1 meter. The cross-section area 100 centimeters square. The elastic module TA. Okay, there's a rod element, that's a cylinder. Okay, it's attached to the wall, and there's a force acting on the other end of it. Okay, it is a 12 kilonewtons, and the cross-section area is 100 centimeters. Okay, the first thing is define K. I just reuse the formula again, EA over L. Okay, so in this case, what is E? E is a 200 GPa. Well, the GPa doesn't make any sense to me because the unit is weird. So I have to convert that into common units. So 200 times 10 to the 9 Newton meter square. Just convert everything to a workable unit. Okay. Area, again, the area is given in 100 centimeters square. I cannot work with it. So I convert that into meter square. So K in this case is is 100 times 10 to the negative 4 times 200 times 10 to the 9. Length is easy. It's 1 meter. Okay. So you have 10 to the 9. Any questions so far? All right, let's move on. Okay, in this rod elements examples or any assignment, first step, you define a K. Next step,
What is the unit of the K?
there's a homework for you.
Okay.
Okay, I don't write the unit down for K because it's wasting my time. In any midterm final exams, you'll be doing a lot of matrix. Okay, and yeah, seriously, don't waste time writing unit down. You just move on. Make it faster. Okay, first of all, you define a K, then you redraw, simplify the rod elements into a spring. Okay, so that thing has a K. It is U. Okay, we name that note 1 and note 2. Okay, instead of I and J, let's call it 1 and 2. And then note 2 will move as well. Note 1 will move U1. Note 2 will move U2. Okay, and of course, there's a force acting on it. It's called F1, F2. Okay, nothing fancy. I just repeat what I had in the previous page. UI, UJ, I just name it U1 and 2 right now. Okay. So now let's use this matrix form and assemble simulate our problem. So this is the force factor is F1 and F2. Okay, and we have a K. It's 2 times 10 to the 9. Okay, and what we learned before. Okay, the matrix format for the spring elements is 1 1 negative 1 negative 1. So we developed that previously. We just reuse it. And then it also has a so any questions so far? We have a force matrix, a force vector, stiffness matrix, and a displacement vector. Okay, so
Yeah.
what is it?
Sorry, go ahead. Oh, I was just gonna ask, so the force 1, it's going towards the right, and same with force 2. Is that just us making an assumption?
Yes, we we have to assume each node has a force and each node has a displacement.
Okay, thank you.
Now it's coming to your questions. what are those forces? Now it's time to apply the boundary conditions. Okay, let's work on the displacement first. U2 is something that we don't know. We're looking forward. Okay, what is U1? U1 is attached to the wall, right? So in this case, U1 is 0. And U2 is something that we want to know. Now let's go on to the left side.
How do we know U1 is attached to the wall? Are we assuming it's attached to the wall?
Because I said so.
Oh, sorry, yeah. Okay,
Yeah. Okay. Because I said so, it's glued to the wall.
okay.
Now, F1. F1 is attached to the wall. Is it 0? No. It's attached to the wall. So if something is attached to the wall, and when we are pulling, okay, how about F2? F2 is given. $12,000 kilonewton, sorry, 12 kilonewton. So it's 12,000. Okay, do we apply any boundary condition on F1? Is F1 0? Not really, not really, because we are pulling something. So F1 has to be there, so it doesn't move. So we'll leave it as F1 as unknown. All right, so let's do the matrix multiplication. F1. Okay, 0 times 1, and then right here is a U2 times -1. So it becomes negative U2. Get it so far? Okay, and then we do the same thing right here. It's 2 times 10 to the 9. Any questions so far? It's just a very simple matrix multiplication. Oh, by the way, I saw the question on chat. Are we allowed to use Excel or Minitab for tests? Yes, you may use anything. Excel, any fancy computer, fancy calculation. But show me the steps in your midterm or assignment, whatever. I want to see the steps right here. How you develop the matrix. I want to see the spring elements diagram. How you develop the matrix.
So shouldn't you be putting negative U2 there? -2 times 10 to the 9 times negative U2?
You talking about first equation or second equation?
The first equation.
First equation I
F1
did.
equals, yes, because you're using -2 times 10 to the 9, U2 times, isn't it 2 times 10 to the negative 10 to the 9 positive? Maybe I'm misunderstanding something.
Okay, we have 0 times 1, and then next
Oh,
U2
sorry, I
times
missed
-1.
0. Yeah, okay, sorry.
Okay,
Yeah, that makes sense.
and then for the second equation is 0 times -1, and then U2 times 1. Okay, for this, we have U2 equal to 6 times 10 to the -6 meter. And now we have U2, we put U2 back to the equation there, F1. Well, that makes sense, right? Because we have F2 is a positive 12 kilonewton. The F1 has to be negative 12 times negative 12 kilonewton. Why? Because due to the free body diagram, if I have 1/4, okay, is that rod moving? That rod is not moving at all. So we have force acting on one note. The negative force has to be there to hold it in place. So balance out the net force, total force act together is 0. So the rod is not moving at all. If I have something less than 12 kilonewtons pulling on the wall, the rod will be flying. So congratulations, you just finished the first assignment, first example on FDA. Okay, one example is not good enough. Let's do another one. Okay, we have an example 2. Okay, now this time it's not that easy now. We have 2 elements. Okay, wow, so messed up. One element is bigger than the other one. They're both the same length. Okay. Okay. I just simplify everything by 2 spring. That's the first step. Okay. Second step, you name them. It's note 1, note 2, and note 3. Okay. And each. Okay, so guys, be careful. In this case, K1 is not equal to K2 because K1 is stronger. Okay, I have that in a note already, how to develop the K1, K2. I'm not going to go over that now. Anyways, K1 now, let's see, how do we link 2 elements together? Okay, don't let it scare you. Okay, we just develop. I'll show you how it works in the first principle of spring elements. Okay, now I'm standing in note 1. I'm standing in note 1. Okay, and the force is acting on note 1. And the delta length, delta changes in a length. It will be the changes. The delta L for K1 will be, I'm standing in note 1, right? So it will be U1 minus U2. Let's do the same thing with a F3. Again, I'm standing in F3. I'm standing in note 3. So I started with a U3. The only thing that changed the length of a K2 is note 2. So will be in this case will be U3 minus U2. Okay, let's do the complicated one. F.
Sir,
Yes, what's up?
I'm assuming for this question, we're just trying to find the overall displacement at node 3. Is that correct?
Yes.
Okay.
After you do this matrix, you are able to tell the displacement of node 3 and node 2 as well. And we all know node 1 is not moving, so U1 will be 0.
Professor, just a quick question.
Yeah, what is it?
Where you wrote K1 is equal to 4 times 10 to the 9. Is that a negative sign behind K1?
There isn't. Sorry.
Okay, thanks.
And we got the
Good
K by
question.
EA over L, right? Is that
E over
correct?
L, that's right, same as before. EA over L.
Okay.
Okay, where are we now? Okay, we have F1, we have F3 defined. What about F2? It's a bit messed up, right? But not to worry, same thing. We are standing in we're standing in node 2. The movement of the change in the change in the length of K1 is U2 minus U1. But is that the only movement? No, because the movement of node 2 is also depending on the right side as well. The movement of the change in length of K2. So we always use plus. We let the displacement tell us is plus or minus. The change in K2, but I'm standing in node 2, right? So I always start with a U2 minus U3. Questions so far? Okay, let's move on. So we arrange the equations. We just expand the term, say K1 U1 minus K1 U2 minus K1 U1 plus, that one is messed up. It's 2 terms. K1 plus K2 U2. And finally, it's minus K2 U3. F3 minus K2 U2 K2 U3. Okay, why I did this? Because I want to align. Oh, sorry. I want to align all the U1 in one column, or the U2 in one column, and all the U3 in third column. We arrange everything together. We factor out U1, U2, and U3. What do we have? F1, F2, F3 equal to, watch this, K1 Okay, guys, did I confuse everyone? Are we still friends? If you have questions, it's time to ask me. Okay, hearing none, I assume we're all good. So what do we see here? We have a big force vector. Instead of 2 entries, we have 3. Why? Because the whole problem has 3 nodes. Node 1, 2, 3. And we have a displacement factor as well. Instead of 2 entries, we have 3 entries. Why? Because we're 3 nodes, U1, U2, U3. And we have a pretty messed up 3x3 matrix. Why is that? Because we have 3 nodes. 3 nodes, so 3x3 matrix. And within that matrix, what do we see? I see a tiny matrix here, which is the first element. And I see another tiny matrix here. Which is the second element. Okay. So let's apply this mess into our problem equations here.
Chris, one quick question.
What is it?
Are you okay if we fill in zeros for the other locations within the matrix?
Like this,
Correct.
right? Yeah, you can do it, but I don't,
Okay.
because again, I want to save time.
Right.
In your test, in the midterm exam, you'll be doing a lot of this, right? Any second you save, which is good for you, right? So you may write 0 there, but I'm not, if you don't, I'm not going to deduct any marks on you. But I want to see a 3x3 matrix. I want to see a force factor. You want. Okay, let's apply
Hey,
it.
Chris, another question. If you go back to the where you define the equations for F1, F2, F3, real quick.
Right here.
Yeah, so this K term, how do we apply this K term for, let's say F1 is K1, because the force is basically due to the change in the K factor of the first element, right?
Force is acting on node 1. Yeah. Oh, sorry, what was your question again? I did nothing fancy. I just assemble,
Right, so I just wanted to
F1.
know the logic behind the K1 and K2. So for force 1, it's basically due to the element 1. So that's why the K term is for the element 1, right? At node 1.
Yep. The
Okay.
force always acting on node. Okay, good question. Force always acting on node. It doesn't act on elements.
Right.
The elements tells you the stiffness. The K1 tells you the stiffness of the elements. And again, U1 and U2 tells you the displacement only. Okay, what I did is just force 1 acting on node 1, and the changes due to that force 1 is U1 minus U2. And for the second equation, force is acting on node 2, and the changes in length for K1 is U2 minus U1, and the changes, how it squeeze K2 is U2 minus U3. Once you understand these 3 equations, I just expand it and convert that into matrix form.
Yeah, everything else after is pretty logical.
Yeah.
Yeah.
But that's the key thing, the first step. Okay.
Yeah. Got it. Thank you.
No problem. Okay, now we plug in all the numbers. Okay, sorry, it's not Fy, it's F1. By the way, I made a mistake in the previous diagram. There's a force acting on node 2 as well, which is 10 kilonewton. Note 2 is 10 kilonewton. And note 3 is 12 kilonewton. Okay, any questions so far? I just plug in the numbers to the matrix. Okay, by the way, in your test or exam, you don't have to show me this. Okay, it just show you the development of the rod elements, how to use it. Okay, if you when you set up the diagram, when you set this up, I need it. I want to see that how you define a K. I need that too. But this step is the development of the how to link two elements together, right? You don't have to show me this, but you have to understand. Okay. Once you define a K, you can jump to this step. Now, now we have 3 equations, right? And how many unknowns do we have? 1,
3.
2, 3. 3 equations, 3 unknowns. We love it. Okay, so we solve everything together. And how to solve that is already written in notes. At the end, you have U2 5 times 5 times 6. 3. 5 times 10 to the negative 6 meter. That's it. Any questions?
Do we solve more than 3 unknowns?
If you have 4 equations, then you have 4 unknowns. Good questions. Okay. The amount of unknowns is equal to the size of the matrix. You have a 3 by 3, you have 3 unknowns. 4 by 4, you have 4 unknowns. Just to
So
give
we
you a
only
clue.
found U2 and U3 only because the question was looking for the change in the length, not the force, right?
Change on the length. Yeah, well, depends on what I asked you. In this case, I only asked for displacement of U2 and U3. Okay.
But what if we
And,
wanted to know the
but
force? Force
then
one.
we just put U2, U3 back to there, and you can calculate F1. And it's on my note. In my note, I calculate F1 as well. Okay, just curious, without doing any FEA, what is F1? I have 2 forces acting on U2, acting on note 2 and note 3.
22.
23 times 10 to 3 because nothing's moving.
That's right. F1 will be negative 22 times 10 to 3 Newton. Nothing's
Just
moving.
adding it, yeah.
Yeah, that's right. Okay, that's it for rod elements. Okay, and I have a homework for you. Okay, usually, I have an in-class quiz, and I give you like 20 minutes, 30 minutes or so. You work on a problem set, and then I collect it at the end of class. But now, because it's only distant learning, have fun. You can work on it on your own. Let's see, what is the due date for it? Yeah, that's right. This is quiz number 1. Oops. Nope. Wrong folder. Guys, can you check? Do you see that assignment in your inbox?
Yes.
Yeah.
Yeah, I think you need to download it first in order to see the file.
Okay. Yeah. Anyways, go work on it. And yeah, nothing fancy. No, that will be. It's due on next week. Okay. Okay, that's long enough for rod elements. Let's take a short break. How about let's come back to my class at 10:30. So, and I want to show you another element. Is that good?
Yeah, sounds good.